In 1976, Stanford built an AI system called Mycin. It could identify bacteria causing severe infections, such as meningitis, and recommend the correct antibiotic treatment based on the patient's symptoms, weight, and lab results. But it was never used on a single patient. Not because it wasn't intelligent. It received an acceptability rating of 65%, while real doctors ranged from 43% to 63%. It was as good, if not better than, most infectious disease specialists. It failed because of something much more mundane. Doctors had to spend nearly an hour manually typing patient data into a computer terminal before the system could even work. It didn't save any time, it just created more work. Today, patient records can be searched and transferred almost instantly. But the principle behind Mycin's failure still haunts modern AI. Take software engineering. It is arguably the domain AI is best at right now. Tech CEOs have been saying AI will soon replace most coders since 2023. The hype is understandable. Coding agents keep demolishing benchmarks and winning competitions. They can generate code 10 times, maybe even 100 times faster than a human. And yet, the number of job openings for coders has only increased. So what's going on? See, the problem is that AI still hallucinates. And many experts think that will never go away. This means no matter how fast AI generates code, at some point, a human still has to verify the code actually works. So even though coders now spend less time writing code, they spend way more time debugging. In system science, this is related to the theory of constraints. A system is ultimately limited by its slowest and weakest component. Think of a water pipe. You can widen almost all of the pipe as much as you want, but as long as there's one narrow section, only so much water can come out the other end. Jobs works the same way. Most jobs are not one task. They are many interconnected tasks. So improving one task doesn't automatically eliminate the entire job. It just shifts the bottleneck to somewhere else. For Mycin, it's typing. For coding, it's debugging. But that's not even the only bottleneck. There's also code design. If you ask AI to generate code without a clear and comprehensive design, the result is often inefficient, disorganized, and hard to maintain. Now, newer AI systems have gotten better at debugging and design, so maybe these bottlenecks will eventually disappear. But even then, replacing all coders is still harder than you think. To see why, we need to look at Mycin's successor.
Even a broken one of these on your wall is right twice a day. Watson.
What is clock?
Clock is correct. And with that, you move up to 23,000.
Some of you might remember Watson, the AI that famously won Jeopardy in 2011. But IBM didn't spend billions of dollars just to build a trivia AI. Watson was actually designed to help recommend cancer treatments. Unlike Mycin, Watson had digital patient records, so no need for typing. And unlike modern LLMs, it used a symbolic system instead of a neural network, so it couldn't hallucinate. It even made it into the hospitals. But within a few years, the project was shut down and sold off for parts, because it kept recommending unsafe treatments. What happened? See, Watson was trained on clean and standardized data, but real hospitals are chaotic. Different doctors use different jargon and abbreviations. Records are fragmented and incomplete, and many patients have unusual combinations of conditions that don't appear in training data. All of these exceptions to the rule were throwing Watson off. In system science, this is related to the last mile problem. The phrase came from telecommunications. Building the main cable infrastructure across a country is pretty expensive, but the last mile connections into individual homes is even more expensive because every neighborhood, every street, and every building comes with its own unique obstacles. This is also why self-driving cars have been just around the corner for more than 2 decades. In normal driving conditions, AI performs pretty well. often safer than humans. But the real world is full of exceptions: unexpected objects, unusual weather, unpredictable humans. Conditions that humans handle intuitively, but AI fails catastrophically.
Waymo, the self-driving car service, is recalling over 1,200 vehicles due to a software flaw that caused some of them to crash into chains, gates, and other roadway barriers.
And it gets worse. Every industry, every company, and every environment adds more and more exceptions, requiring more specialized AI training in every case. Researchers at Harvard Business Review argue that this last-mile problem may become one of the biggest bottlenecks, slowing AI adoption. So even when AI becomes highly capable at the job level, the bottleneck just moves to the next level. But let's say we eventually solve this problem too with an AGI, artificial general intelligence that can handle every real-world environment. Even then, there's still another bottleneck. And this one took me many years to understand. For a big chunk of my career, I was a software engineer. I've built sophisticated automations for some pretty big clients. I am, on paper, pro-automation. But every now and then, a client would quietly stop using the automated system after a few months. Not because it didn't work. It worked perfectly, even with messy real-world data. One client, for example, manufactured home appliances. Their customer support team was overwhelmed with constant phone calls. They wanted a more efficient system. So we replaced the phone number on their website with an intake form that automatically created support tickets, generated initial responses, assigned the right employee, and reminded them about unresolved tickets. And technically, it worked. Tickets moved much faster, but their customers got more frustrated, and the reviews got worse. Finally, one of their managers decided to personally call a few loyal customers to figure out what was actually happening. And that's when they found the real problem. It wasn't the speed of the customer support or the quality of the appliances. It was the instruction manuals. They were bulky, dense, and confusing. Most customers didn't bother to read them, which caused preventable mistakes that flooded their customer support in the first place. So the company added a quick start sheet along with the manual. It's got intuitive graphics that quickly explain key features of a product. Later, they even redesigned some of their appliances so that customers barely needed instruction at all. And the most surprising thing was that they switched back to phone-based customer support, because they realized actually talking to the customers gave them way more product insights and customer satisfaction. See, the automation didn't solve the problem, it just covered it up and made it worse. That experience fundamentally changed how I approach systems design. I stopped seeing them as mere computer systems and started seeing them as human systems. Because a powerful technology means nothing if it doesn't actually solve any human problems. The now defunct Sora was a perfect example. It could generate very realistic AI videos, but it didn't make people's lives better. It only made them distrust AI more. And history is full of such failed technologies.
You've got to start with the customer experience and work backwards to the technology. You can't start with the technology and try to figure out where you're going to try to sell it. And I've made this mistake probably more than anybody else in this room.
In business, this is called product market fit, our third bottleneck. But here's where this gets interesting. When the market finally adopts the technology, it often creates more jobs, not less. When ATMs become widespread in the 90s, many people assumed bank tellers would disappear. Instead, the number of tellers actually increased. Why is that? Because ATMs not only reduced the operating costs of banks, they also made banking more convenient, which attracted more customers. So the banks opened more branches. This is called demand expansion, and many economists think AI could trigger the same effect. Especially in industries that were historically too expensive for many people to fully access, like healthcare, finance, and legal services. If AI dramatically lowered costs, millions of new customers could suddenly afford services they couldn't before. Hiring a software company to build a custom inventory app used to be prohibitively expensive for small businesses, but soon they might be able to hire a junior coder with AI assistance to build these custom apps. Even regular consumers might be able to go to a store and have someone build a custom calendar app as quickly as an oil change. So as everything becomes cheaper and more accessible, the demand for them can grow dramatically. This means AI might eventually create more jobs than it replaces. Now, as optimistic as this sounds, there's still one more bottleneck that we haven't talked about yet, and it might be the hardest one to overcome. In 1882, Thomas Edison built the first commercial power plant, but it took about 50 years before electricity significantly impacted every single job. At first, many factories used electricity in the least transformative way possible. They simply replaced a giant steam engine with a giant electric motor, while keeping the exact same factory layouts and workflows. In other words, they were stuck at the first bottleneck, at the job level. The real transformation came later, when factories, offices, homes, and entire cities were redesigned around electricity itself. And that required far more than just better machines. Businesses needed massive capital investments to rebuild infrastructure. Electricians and electrical engineers had to be certified and trained. Governments needed to approve new safety codes, insurance systems, and legal frameworks. The bottleneck wasn't just the physical infrastructure, it was also the social infrastructure. This happened to computers too. Despite being powerful tools for decades, most workers barely interacted with them. Restaurant waiters, for example, couldn't care less about computers. It wasn't until cheap smartphones, wireless internet, and cloud software all matured together that computers finally transformed how restaurants operated. Now, many people argue AI will spread much faster because it can ride on top of the existing internet infrastructure. Maybe, but it's already hitting other infrastructure bottlenecks.
Boom, as more than half of the country's planned data centers for this year alone have been placed on hold. Bloomberg reports a severe shortage of electrical equipment is driving the slowdown.
The amount of load that these racks and these AI ML infrastructure based data servers that we're building, there simply isn't a way to build enough energy infrastructure to be able to not only handle the constant load, but also any kind of surge loads.
And that's not all. Workers still need to be trained to use AI safely in every industry. Laws need to be updated on who owned AI-generated work, who is responsible for AI-caused damages. That's not even getting to the fact that most AI companies still operate at a loss to subsidize pricing for the users. No one knows if these productivity gains from AI are even commercially viable in the long run. Now, just because these infrastructure bottlenecks might slow AI adoption doesn't mean we should wait around and do nothing. Many companies already claim they've replaced workers with AI. A lot of that is AI washing, using AI as an excuse to lay off workers that were the result of overhiring. Some of it is genuine AI automation, mostly in narrow jobs built around simple, repetitive tasks like data entry. But the companies that try to automate complex jobs are now regretting it. There are quality issues, safety concerns, and it's just unclear if AI is actually making things more productive. The exact bottlenecks we've been talking about. So short-term job disruption is going to happen, not because AI is quickly taking over, but because CEOs are greedy and impatient. Many people could still lose financial stability before new jobs are created. This is why we have to be proactive in this AI transition, to ensure that it delivers more benefits than harm. After all, we the people are the real infrastructure of our society. We're the ones who can ultimately shape our institution, our values, and our futures. Now, this video assumes we'll eventually achieve AGI, or even superintelligence, but we're nowhere near that. There are still many technical barriers that limit AI capability. Some of them might never be overcome. Check out my previous video where I dive deeper into the math and science behind these limits. Also, many of these systems principles we explored here don't just apply to AI. They also shape economics, politics, ecology, and personal resilience. I made a playlist for people who want to explore these further. Lastly, if you'd like to support my work and help my team rely less on ads and sponsors, there's a Patreon link in the description. No pressure. Thank you for being here.